All right, this video pertains to Module 4 Homework 2, and it's talking about complex numbers. Now, complex numbers have a set of rules that you follow with them. So let's take a couple examples through the questions that we have here and find out. Now, a couple things about complex numbers is that complex numbers are in the form of a plus bi, where a is the real part and b is the imaginary part. Well, the whole entire thing is really imaginary part. It's the coefficient of imaginary part. So I just say it's imaginary. Right? So when I look at this, okay, which is in the complex standard form, I need it in this form where this is not in its proper form. If I look at 4i plus 9, if that means that would be bi plus a, and that is not the proper setting. This is proper, all right? And we can have complex numbers having 4i. That just means that the a is valued as 0. All right, so this is appropriate. Okay, now this is inappropriate. You can't have radical 4 like that. That's inappropriate. Negative radical negative 4. That would be where it's inappropriate. So we have this one. We have this. Hold on. All right, they don't allow us to pick multiples. Actually, in all sense, okay, all of these right here are all correct, by the way. What they really wanted you to do, if they are doing it that way, they're doing it this way. Radical 9 is 3, but they wanted you to put the 0i. And then they want to go ahead and put for 9, they want to go ahead and put plus 0i. So that's why they're saying it. So the only answer that works is this one, because it's in the proper form of a plus bi. Even though these are all correct too, this one's most appropriate for the standard form of the a plus bi. Okay, so that's why the answer is that one. So if we look at this, another thing is that we're looking at the square root of -1. Now the square root of -1 is not possible. There's no two numbers that when they're perfect squares, can equal -1, because 1 times -1 is -1, and these are not the same two numbers that multiply together to create that number. So now what we use then is I to represent that. So I represents that. So we say simplify the following expression. Radical of -1 is going to be I. That's your answer for that. All right? So now I squared is going to be equal to -1. Okay, that's what I squared is. So you need to have this information for yourself in order to operate within complex number systems. Now it says write the standard form of a complex number using A for the real part and B for the imaginary coefficient. So that's what I was talking about before, it's the coefficient. And it says write the standard form. Now, when we're talking about that, okay, they're looking for this right here, A plus BI. That's what they're looking for. All right, so that's the answer they want. Now it says write this in standard form. So when you're writing this one for D, we're breaking it up into two parts, where this is the real part and this is the imaginary part. All right, that's the coefficient of the imaginary part. So then you're going to get this to equal 2, and this equals 4, and then the I. And so we're looking for this as an answer in standard form. Now, the real part of this is going to be the 22, because it's in the A position. And the imaginary coefficient is going to be 4 for this one. So this one moves, this moves very quickly. It's understanding the breakdown of the imaginary complex number system. Anytime you have a negative value, don't worry about it. All you do is take it out as I. Immediately, whenever you see a negative sign, just do this. Okay? Immediately, please. Whenever you see a negative sign and it's the index is 2, it's even, take out I. Now, once you do that, then you take square root of 121 and get 11, so it's going to be 11i. That's the answer we're looking for number 4. Actually, number 3. Wow, number 3 and number 4 look the same. Okay, so anyway, this is number 3. and then simplify. This is going to be the same exact answer. Wow, that was interesting. So this is 4 and 3. All right, that should be very, very fast. Okay, now when you're looking at number 5 then, number 5, it says simplify this, right? So when we're looking at that, immediately I say pull out the I whenever dealing with radicals that are negative. So take out the I, because it represents that -1. Now, 28, doing that tree thing that's talked about earlier, we could just simply divide it by 2, okay? But I'm going to go ahead and divide it by 4. What the heck? Why not, right? You can. And that's going to, 4 goes into this how many times? All right, we think about our multiplication tables, and it's going to be 7, right? So 4 times 7 is 28. And then we're going to go ahead and the root of 4 is 2. So this is going to simplify out as 2I radical 7. All right, and that's our answer we're looking for. Now, it's more appropriate to put the I in the front than in the back, because this is a big no-no. More no to put the I right next to, or underneath the 7, underneath the radical system. That's a big no-no. So in order to avoid that, even the writing is sometimes sloppy, we always put the I in the front, so it looks as 2I radical 7. The only reason why you would want to put it like 2 radical 7 is because that's the imaginary coefficient, and they want it to be like that. But they'll accept this as an answer as well. Okay. Now, taking a look at number 6, we have the same ideas going on here. We're going to go ahead and take out the I. So we're going to go ahead and take out I right away. All right. And then I go ahead and look at 245. And immediately I'm going to divide 245. I'm going to divide it by 5 and see what happens. And 245 divided by 5 gives me 49, which is going to be 7. Radical 7, or radical 49 is 7. So I'm going to get negative 7I, and then I'm going to have a 5 left over. Now again, you could put this in the front or in the back if you are clear about the way you intend to have that. So that better be very much on the outside. But you can see here that they put the I right here, which is the way I'm just trying to describe it to you. It's a lot easier to avoid mistakes for that reason. Okay? I always break this down. It's more quicker. All right, now you have this negative 8, and we're going to go ahead and pull out the I, make it positive 25. Then positive 25 is 5. 5 times 8 is negative 40I, and there's our answer. All right. That's going to be number 8. When we take out the I, basically we're going to have negative 3I. Radical 4 is going to be 2. 2 times negative 3 is negative 6I. Done. And then we have this. Now, some students would be tempted to go ahead and multiply. Negative times a negative is positive. You can't do that. Okay. Go ahead and take the I first. So it's I. And then 6 is 3 times 2, which can't be simplified any further. But then when we look at this, right, we know that 54 is 9 times 6. And remember before what I told you, if we want to look at when we multiply these together, then I times I is I squared, right? Well, what does I squared equal? I squared equals negative 1, right? So then when we do this, we're going to get the 6 comes out of the radical system, okay? And then the square root of 9 is 3. So 3 times 6 is 18. So then because this is equal to negative 1, we're going to get negative 18 for our answer. All right, that was me really identifying to the properties of the complex number systems. Now I go ahead and do this. Number 10. I see that it's going to be I radical 3. Can't do anything with that. But then I have I, I times I is, I'm just going to put a negative sign in front of it. Okay? And then, because I'm multiplying it now, and it's going to be 3. Because, it's kind of crazy, is that the negative 1 is I, and then you have a negative, or you have a negative 1 kind of buried inside of this one. So that's why it's I squared, and I squared we know is negative 1. So that's going to be valued at the negative sign. Now the square root of 9 is 3, so therefore we have our answer right here. That was a kind of a fun one. I enjoyed that. All right, now let's look at number 11. I know you're probably thinking to yourself, how in the world do you enjoy this? Well, I mean, when you know the engagement rules, like you know how to operate with them, it is really enjoyable. Like, I really didn't need to be writing down the square root of 5. I mean, excuse me, I meant to put 5. So I already know the answer. The square root of 25 is 5. And that's why I accidentally put 5 because my mind is working so fast. I can do it while I'm talking to you. So, but when I have that, I'm going to have this. And there's our answer. These do move very, very quick. All right, number 12. All right, so we're going to go ahead and simplify this as, see, now I'm going to just go ahead and start working it out. It's going to be 3i, and it's going to be minus 8i, all right? And then I'm going to go ahead and get negative 5i. They move very quickly, like that. So now when we have operations involving like this, question number 13, we're going to go ahead and just add our real parts together. So what is 3 plus 5? And then what is 2i minus 2i? That's going to be 0, so our answer is 8. 14. We're going to again add our real parts together, so 22 plus 8 is 30. And then I'm going to have negative 23 added to 6, which gives us 17. Negative though. All right. So just going ahead and making sure we just go ahead and take the 23 and minus the 6 from it, and then just keep the sign a larger value. Oops. And now, whenever you have subtraction involved, you know you're supposed to do the distributive property. So this is actually 14. Yeah. So now you're going to go ahead and distribute the negative sign. The way I look at it is really then this way. So distributing the negative sign, then you combine your real parts together. So that's going to be negative 22. All right. Adding 8 is going to give us negative 14. And then adding these two parts together, we're going to get negative 29i. We have that answer. So that's what we're looking for our answer. Now we're doing still the same idea, is we're going ahead and combining like terms by adding. So we're going to go ahead and combine 4 to negative 7 and get negative 3. And then when we do the negative 25, it's going to be 5i. So that's going to be 5i. So rewriting that, it's going to be 5i minus 5i. And then it's going to be plus. And then that's going to be positive 7i. So then when we go ahead and add these two parts together, that's where the negative 3 comes from. But then when we add these two parts together, it's going to be positive 2i. Now, likewise, since we've already done this, when we do the subtraction, we're going to just take and switch the sign to this one and to this one. And so this is going to be positive 7 minus 7i. That's going to give us 4 plus 7 is 11, and then these added together is going to give us negative 12i. Now, you're probably thinking I'm going too fast. I'm keeping it simple. I mean, maybe it's fast for you because you can't add and subtract in your head as I'm doing. You've got a calculator to do that. Now, sometimes, I mean, my brain gets into a knot because everybody does, and thinking can't happen sometimes, so I just use it as a calculator. I mean, even sometimes doing 22 minus 8 or whatever, I mean, it's just your brain works differently, right? So whatever, doesn't make a difference. You're just going to go ahead and just do what you got to do to get them simplified. Because this isn't that complicated. You're adding the real parts together, the A parts. So then when you're looking at 16, what is 24 minus 9? Well, that's negative 24 minus 9, right? So then you're going to go ahead and put down 33, negative though. And then you're going to go ahead and add 8 to the 14 and get 6. Okay? So now it's going to be positive 6i. Likewise, you do the same thing for the next one, but again, you have a negative sign, so you got to switch the signs when you do it. So it's going to be taking negative 24 and minusing the 9. So that's going to be 15, and you're going to keep it negative. So it's going to be negative 15, and it's positive 9 added to negative 24. Again, you can use your calculator. And it's going to be negative 8 added to negative 14, which is negative 22. So you can basically do this mentally, but maybe you can't. You know, I'm proving to you you can, but I mean, and again, I'm no genius. I'm just going ahead and retaining numbers and adding in my head and stuff. Sometimes that does throw me off, and sometimes I can make mistakes just like these ones. Now, when you're looking at this one, and you have this, I think of I in terms of the wheel. We have I, and then we have I squared. We have I to the third, and then we have I to the fourth. I, as we discussed, is the square root of negative 1, right? This is going to equal negative 1. This is going to be a negative 1 times a negative I, or 1, the radical of negative 1. So you're going to have this, okay? So then you're going to go ahead and have this one as 1. Now, we don't go ahead and write it this way. So whenever we have just this as a resulting value, we're just going to simply put I. And then anytime we have I to the third, we're just going to go ahead and put negative I for the value of that. So that being said, we're not going ahead and take this. 4 to the third power is 64 because we know our perfect cubes. And then we take I to the third, meaning I'm going to go ahead and put negative I. That comes up into the 64, and that's how I get negative 64i. So we are looking at this wheel. This wheel is very important. A lot of students like the concept of the wheel. Now, taking a look at multiplication, again, remember that I times I is I squared. We're going to get negative 5 times 11 is 55 I, and then we get I times I is negative 1. Remember, I squared is negative 1. But then we have negative 5 times 4, or 8, excuse me, is negative 40. And that double negative equals positive, so it's going to be positive 40. So what I do is, whenever I see I times I know it's going to be negative 1. I multiply the coefficients of those i's, and I see that it's negative 5 times 8 gives me negative 40, and then I take this and switch the sign. So that's why I get positive 40. Now, this is not an appropriate way of display. We want to put it in the proper A plus BI form, so it's going to be 40 minus 55i. All right, now we're going to look at this one. where we have 8 times 9, and then we're going to go ahead and do 8 times I. 7I times 9 is positive 63I. And then I times I is negative 1. 7 times 1 is 7, which gives me negative 7. Now I combine these two together. I think it's 72 minus 7, that's going to give us 65. And then I'm going to go ahead and add these two together. That's going to give us 71. Okay. A couple more to do. All right. Now, when we're dealing with perfect squares, okay, these are perfect squares, you can follow the formula, but it gets a little bit tricky. Sometimes I'm going to show you how to operate it. Watch this. Okay, so we're going to do it like normal. Not like normal, but we're going to go ahead and FOIL it out and see how we can make a connection to this right here, this formula. And by the way, this is negative, so we're going to go ahead and put minus. We always want to make a relationship to this right here, because this is the formula for perfect squares. So what we have here, though, is imaginary coming back. So let's take a look at that. So now, it's this times this is going to give us 4. This times this is going to give us negative 12. This times this is going to give us another negative 12i. And then this times this is going to give us positive 36i squared, which is negative 36. So we look at that, okay? All right, when we're dealing with I, all right, and I'm gonna change this up a little bit. But then we get 4, and then it's going to give us negative 24i minus 36. We've got to bring these two together, okay? And when we bring these together, we're going to get negative 32 minus 24i. And so that's the answer we're looking for. All right. Now, the thing is that when we do this, okay, we have a tendency just to go ahead and keep a positive b squared and stuff like that. But it's going to be negative. So whenever we have this, okay, involved with I squared, it's going to be the a squared minus 2ab, like we did here, because if we go ahead and multiply them together, it's going to give us negative 12i, and then we double it, and it gives us the 24i. But then we're going to go ahead and do this, where we have the negative b squared, okay? Whenever the value is squared, remember, it's because it's going to be the I times I and gives us negative 1. This is going to be negative b squared. And then what then happens is the a squared is then added to the b squared, and then we have minus 2ab. When we're dealing with I should go ahead and do that one, okay? Let's go ahead and throw that I in there. I like that, okay? So now we have the formula, all right, for when we are dealing with perfect squares. Now that's something that's unique from your instructor, from me, but most teachers just tell them to go ahead and just blow it out. And most of you probably will, okay? But now I do want to share with you the 21 when we have then the different two squares. By the way, this is complex conjugate. When we have this, it's going to be this formula that we're going to use. A squared plus, excuse me, yeah, b squared. It's going to be when we have a plus bi times a minus bi equals that. kind of trim that in here. Sorry about that. So now, so all I got to do is take and square these together, or multiply them together, so square it, and that's going to give me 4. And then I'm going to go ahead and put a plus sign, and then take and square the 3 times 3 is 9, so I get that as my answer. And here I'm done. The I, remember this part right here, they're going to cancel each other. So we don't do it that way for that reason. So like these parts will be opposite in signs at this point, right there at that point. So that's why our answer is just simply going to be 13. So that moves very quickly. Now, the last and final question that we're going to look is we're taking the 50, obviously dividing it by 25, we get 5. Or screw me, 25 is 5, and then I'm left with 2. So the thing is, I'm going to simplify this as this. Now, it wants to express it into a plus bi form. So what we're going to do is go ahead and bring this together. So it's going to be 1/3, that's 2/6. And it's going to be then 5 radical 2 over 6, and then the I is on the outside, like that. So this is the imaginary coefficient. This is the A value, and then we have our answer. Okay? So we're splitting it up into 2 parts, and that's why we're doing it, so we can get it in the form of A plus B, even though B might be a negative value. All right? So that concludes this lecture on complex number systems.